Welcome back to the deep dive. For the past few years, the world of artificial intelligence has felt less like a steady technological progression and more like a series of just seismic shifts.
Absolutely. It
Yeah.
feels like every few months we get a new major model, another enormous leap forward that just completely resets the scale of what we thought was possible.
It's exhausting in a way.
It is. And if you track the news, that pace is just hyper accelerated.
Yeah.
But rarely does a model drop that ignites the kind of immediate widespread speculation and frankly, the intensity that we saw on November 18th, 2025.
That, of course, was the unveiling of Google's Gemini 3 Pro.
Yeah.
And the social media chatter was, well, it was instant, it was aggressive, and it was overwhelming.
Oh, completely. The claims were flying.
And these are claims we really need to scrutinize here. People were saying Gemini 3 had, and I'm quoting, left everyone else in the dust.
Which is a tremendously bold assertion.
It's an incredible claim when you're talking about incredibly high-performing rivals. I mean, you have OpenAI's GPT 5.1, which was the reigning champ in many areas.
Right, and Anthropic's Claude 4.5 Sonnet, which had carved out this niche of being the most sort of reliable and safe model.
Not to mention xAI's Grok 4, which is all about speed and real-time data.
Exactly. This is, without a doubt, the highest level of the AI arms race we have ever witnessed.
Which is precisely why our mission today, diving deep into the sources you've provided, is so critical. We've gone through the official architectural designs, the internal benchmarks, the white papers, and the early strategic analyses to evaluate one core question.
And that question is Gemini 3 genuinely a paradigm shift, as so many have claimed? Or is it just, the latest peak in this perpetual AI hype cycle we seem to be stuck in?
Our goal here is to really cut through the numbers, get past the marketing spin, and understand why this specific model is being talked about less as a helpful chatbot, less as an assistant.
And more as what the sources repeatedly call a unified cognitive engine.
A unified cognitive engine. That phrasing alone implies a profound functional difference. It's not just a better talker.
It's not. And if we look at the one strategic implication that really defines this entire model release, it's this. AI dominance is no longer purely about who talks the best or who can, generate the fastest marketing copy. The battleground has shifted.
To who thinks best.
Exactly. To who thinks best. Gemini 3 seems deliberately engineered from the ground up to prove that very point through sheer architectural and computational rigor.
Okay, let's unpack that. Let's get our hands dirty with this shift in intelligence. To understand why it supposedly thinks better, we have to start right at the foundation. This is part one, the architecture and core capabilities, the blueprint of a new model.
So Gemini 3 Pro was developed by DeepMind. That name alone immediately positions it at the absolute frontier of structural AI innovation.
It's a signal of intent from Google.
A huge signal. It's built on their specialized TPU infrastructure and is explicitly marketed as a leap forward in three key areas: reasoning, native multimodality, and, crucially, reliability in really complex tasks.
The sources are pretty clear on this. This isn't just an iterative update like a Gemini 2.6 or something.
Not at all. It's a fundamental structural reset. It's designed for deep, complex problem-solving from its very core.
And the centerpiece of that structural reset is something we've heard of before, but it seems exponentially scaled and optimized here. The mixture of experts architecture, the MoE model.
Right. And we need to go beyond just the simple definition here and really understand the true advantage this MoE design provides in this new model. It's not just a buzzword.
So break it down for us. What is the MoE advantage, practically speaking?
Practically, it's the engine that drives efficiency by design. If you think of a traditional, dense, large language model, like the ones that were dominant a couple of years ago, it's like a single massive brain.
One giant network.
Exactly. One giant network where every single neuron is potentially engaged for every single query. Doesn't matter if you're asking it to, define a simple word or solve a complex differential equation.
Which has to be incredibly computationally expensive for every single request. It's overkill for most things.
Precisely. Massive overkill. The MoE system in Gemini 3 is fundamentally different. It's composed of numerous small, specialized neural networks. These are the experts.
Okay, so it's a team of specialists rather than one generalist.
A perfect analogy. When a task comes in, a very sophisticated router network assesses that task and activates only the 2 or 3 most necessary specialized subnetworks for that specific job.
So give me an example.
Sure. Let's say you ask it for a high-level strategic overview of a potential financial merger. The router identifies this as a complex business task. It might activate the economic analysis expert and the long-form summary expert, but it leaves the low-level coding expert or the, poetry generation expert completely dormant.
So it's not just powerful, it's surgically efficient. It doesn't waste energy and compute firing up all these components that just aren't needed for the job at hand.
That specialized activation is the key. It reduces the computational intensity so significantly. And the immediate practical result of that is that Google can deliver this immense power and scale because the overall model capacity is truly massive. But the per token cost for users and for Google's own inference is much lower relative to other dense models of similar peak capability.
So it's a business model innovation as much as a technical one.
Absolutely. It effectively balances groundbreaking power with practical, scalable economics, which is essential if you want to see large-scale enterprise deployment.
That sets the stage for scale perfectly. And speaking of scale, we absolutely have to discuss the context window. This is the detail that seems to transform the model from a high-level assistant into a system architect.
This is where things get really wild.
We're talking about a 1 million token input window with an output of up to 64,000 tokens.
Let's just pause on that for a second. 1 million tokens.
To provide some context for you, earlier flagship models, even the really good ones, were often restricted to maybe 100,000 or 200,000 tokens. This is a 5 to 10-fold increase. It's a monumental leap.
It genuinely redefines the term long-form reasoning in a way that previous models only ever hinted at. I mean, think about what 1 million tokens actually represents in the real world.
Break it down.
It's the equivalent of over 1,500 standard book pages,
Mm-hmm.
or, maybe more practically for professionals, an entire historical corporate code base.
The whole thing.
The whole thing. Or a full decade of internal legal correspondence and all the associated policy documentation. All at once.
The implication for applied AI here is just staggering. You are essentially eliminating the need for external retrieval augmented generation, those RA systems, for the vast majority of knowledge workers.
That's a huge point. The whole complex industry built around RAG suddenly looks a bit precarious.
Right. If I, as an analyst, can drop in an entire historical legal archive, every internal policy memo, and all the associated external regulations, the AI holds all of that information simultaneously and accurately for reasoning.
Exactly. The nature of applied AI shifts right there. It moves from being a search tool that retrieves relevant snippets for you to analyze.
To a true forensic analyst or a comprehensive historian.
Yes. It can see patterns, it can spot contradictions, and it can find strategic implications across this vast, unified body of knowledge without having to continuously ping external databases or summarize documents sequentially. This depth of coherence is what powers its complex strategic thinking we'll see later in the benchmarks.
It's not just seeing the trees, it's seeing the entire forest and the ecosystem that connects them.
And it remembers the exact shape of every leaf on every tree.
Okay, now let's combine that immense scale with the second core technical highlight, native multimodality. This is a distinction that the sources really emphasize is critical to that whole unified cognitive engine concept.
It is the functional heart of the model. It's so important to understand this distinction. Many older or competing models, they were trained primarily on text, right? And then later on, vision or audio capabilities were sort of bolted on afterwards.
Like a plugin.
Like a plugin, exactly. Gemini 3, however, processes text, images, audio, and video within a single, unified reasoning framework from the ground up. It was born multimodal.
So why is that native integration so important functionally? What's the real difference for the user?
Because it means the model is reasoning over the different data types simultaneously and holistically, not sequentially. It's a huge difference. It doesn't, for example, interpret an image, generate a text caption for itself, and then reason over that caption.
Which is how a lot of the older systems worked.
It is,
Yeah.
and it's a lossy process. Gemini 3 reasons over the image as an image, while simultaneously cross-referencing text and listening to audio. The inputs are integrated at the highest cognitive layer before the reasoning even starts.
And the sources provide a phenomenal illustrative example of this unified capability. Let's walk through that complex flow because it really brings this concept to life.
Certainly. So imagine a complex engineering scenario, a real-world industrial problem.
Okay.
The model is given an hour-long video of a piece of heavy machinery failing in a factory setting. At the same time, it's also given a 200-page technical PDF schematic of that machine and a chat log detailing the operator's actions leading up to the failure.
So you have video, a dense PDF, and text, all as inputs for one query.
All at once. The model then analyzes the video, extract the critical frames showing, say, the color of the smoke plume and the exact readings on a pressure meter at the moment of failure. It then cross-references that specific visual data with the subsection of the technical PDF that relates to that component's failure tolerances.
And then it connects that to the operator's chat log to see if a human error was involved.
Precisely. It synthesizes all three sources of information, and then, based on that combined insight, it generates executable code, maybe a Python script for a new diagnostic system, that could prevent this failure in the future.
That is analysis, synthesis, cross-referencing, and action, all in a single, unbroken flow. That capability alone just unlocks revolutionary real-world use cases in things like engineering diagram interpretation, forensic analysis.
Or even medical diagnostics. Imagine feeding it an MRI, the patient's full medical history, and the latest research papers all at once.
That's a whole other deep dive. So these powerful core features, the efficient MOE, the massive context, the native multimodality, they lead directly into the specialized cognitive modes. This is where the true cognitive shift really seems to happen.
This is where we need to introduce the deep think mode, which, as you said, we're going to dedicate an entire section to later because it's that important.
This sounds like Google's institutional acknowledgement that sometimes speed is the enemy of quality. Deep think mode is described as a specialized high cognition regime.
That's the perfect way to frame it. It's an internal switch. It's not a different model. It's a mode that allocates an extended computational budget specifically for complex tasks.
So you're telling it, take your time with this one. I need the right answer, not the fast answer.
Exactly. When you activate it, it prioritizes analytical rigor, accuracy, and depth over that immediate response speed. And the results are, well, they're staggering. The sources confirm that in internal DeepMind tests, this mode delivered performance gains exceeding 50% in things like advanced mathematics, theorem proofing, and complex algorithm design compared to their previous flagship, Gemini 2.5 Pro.
A 50% jump in performance just by choosing to spend more clock cycles? That is not an incremental gain.
No.
That's a structural revelation. It shows they've unlocked this deeper layer of reasoning that simply requires more time and more energy to activate. It was always there, just dormant.
And finally, to complete the architectural picture, we have to mention the agentic capabilities enabled by integrated tools. This is what solidifies its role as a co-architect, not just an analyst. The model isn't just a solver, it's a manager and an executor of solutions.
And they introduced a specialized tool with a very cool name, anti-gravity. What exactly is this, and how does it integrate with the model?
So anti-gravity is described as an agentic development environment. It's not just an API call, it's more like a secure sandbox where Gemini 3 can actually act autonomously within a system.
So it has agency, it can do things.
It can do things.
Yeah.
This means it can autonomously refactor code within a designated repository. It can debug systems by running iterative tests and analyzing the output. It can simulate outcomes under different load conditions, and it can even propose architectural improvements to an existing software stack.
So it's essentially a high-level executable software architect built right into the AI's capability stack. And it leverages that immense million-token context window to understand the entire system architecture before it even suggests a change.
That is the complete picture of the unified cognitive engine. When you assemble all these pieces, the MOE for efficiency, the million-token memory for context, the native multimodality for rich data intake, the dedicated deep think layer for rigor, and the agentic tools like anti-gravity for action, you move so far beyond a simple Q&A model.
You have a system that is purpose-built for structured problem-solving, for systems design, and for coordinating incredibly complex workflows.
That's the blueprint.
Okay, the blueprint is structurally sound, and the vision is clearly ambitious. But in the world of AI, hype often exceeds reality. The only true measure is the objective data. Let's move to part 2. Benchmark performance. This is where we see if that huge architectural investment actually translated into measurable objective superiority.
And the sources are very, very clear on this. The data strongly suggests it did, particularly by confirming a real shift in what the performance metrics are even measuring.
What do you mean by that?
We're moving away from simple metrics of, say, pattern recall or knowledge retrieval, and we're moving toward measuring true fluid intelligence.
The capacity to reason through novel multi-step problems that the model have never explicitly encountered in its training data.
Precisely. It's about problem solving, not just knowing things. And the high scores we're about to discuss confirm that the structural innovations we just laid out, the MOE for scale, deep think for rigor, and that massive context window for coherence, are actively combining to push the raw numbers higher than we've ever seen before.
Okay, let's start at the top with the benchmarks that validate high-level and abstract reasoning.
We begin with GPQO Diamond. This is recognized globally as one of the toughest PhD-level reasoning tests out there. In its standard mode, Gemini 3 Pro scored an already exceptional 91.9%.
Which is already state-of-the-art. But when it's activated with Deep Think mode, that specialized slower state we just introduced, that number jumps to 93.8%.
Now compare that to the closest competitor, GPT 5.1, which scored a very respectable 88.1%.
So as the host, I have to ask the critical question here. Is a 5.7% difference at that absolutely level genuinely a vast gap, as some have claimed, or is that just statistical noise in a hyper-optimized system?
That's the right question to ask. And in a field where previous models struggled for years just to break the 90% threshold, that 5.7% difference is qualitatively significant. It's not noise. These questions are designed to test synthesis, inference, the creation of novel connections, not just recalling facts. That gap confirms Gemini 3's structural leadership in the most rigorous intellectual domains.
It's a real lead.
It's a real lead, but the difference becomes truly qualitatively massive when we look at entirely novel reasoning tasks, specifically the ARC-AGI-2 benchmark.
Okay, let's unpack ARC-AGI-2. What is this test conceptually, and why does it matter so much in the AGI conversation?
ARC-AGI-2 stands for Abstract Reasoning Corpus Advanced General Intelligence. It's a test designed by researchers trying to create a benchmark that requires minimal prior data and maximum abstract reasoning. It often involves solving these visual and abstract matrix transformations.
So it's like an IQ test for AIs.
A very good analogy. It's about identifying underlying principles in a grid and then applying them to a novel, unseen grid structure. It tests human-like intuition and logic transfer. And previous models have always struggled profoundly with it because they rely so heavily on massive training data rather than true abstraction.
They're great at interpolation, but not extrapolation.
Perfectly put. And the sources report a massive, massive jump here.
What are the numbers?
A near doubling of the previous state-of-the-art, or SOTA. In standard mode, Gemini 3 hit 31.1%. But when it was paired with DeepThink and its agentic tools, it soared to 45.1%.
45%. And to underscore that gap, GPT 5.1 scored only 17.6%.
That's right.
That jumped from 17.6% to 45.1%. That truly validates the claim of structural innovation. This isn't just optimization anymore.
No, it's proof. It's proof that the MOE architecture, when it's enhanced by that deliberative deep think process, is generating true abstraction and flexible problem-solving ability. It's succeeding in domains previously considered a deep moat for human intelligence.
It's the closest measurable proof that the model is mastering what researchers call logic transfer.
It is. And then there's the appropriately and perhaps ominously named Humanity's Last Exam.
Which is a composite test of high-difficulty human knowledge domains, right?
Yes, it pulls from the hardest problems across multiple fields. Here, Gemini 3 scored 37.5%, and it hit 41.0% with DeepThink. The closest competitor, GPT 5.1, was way back at 26.5%.
That's a 14.5 percentage point difference.
The sources note this is the largest gap seen in that specific test since the initial release of GPT-4. It's a huge margin.
These abstract reasoning results really solidify the narrative. Gemini 3 is fundamentally engineered to think more rigorously and more conceptually than its peers, but I have to say, perhaps the most surprising and decisive figures come from symbolic reasoning and mathematical supremacy.
I agree. The math results they're revolutionary. There's no other word for it. Let's look at the AME 2025 benchmark, which tests PhD-level mathematics proficiency. Gemini 3 achieved near-perfect performance. It scored 95.0% without any tools, and a perfect 100% when it was allowed to use its internal code execution capabilities to, write and run Python scripts to check its work.
100%. And what were the competitors scoring?
Single digits, around 7% or 8%.
That's not a competition. That suggests the model has transcended simple calculation or pattern matching.
It confirms that the model is truly mastering the symbolic language of mathematics. Things like complex algebra, number theory, advanced calculus. It's doing it in a way that previous large language models, which, let's be honest, often struggle with basic arithmetic, never could.
They're solving these problems based on a structural understanding of the math, not just on pattern completion from their training data.
That's the leap. But the metric that, for me, really defines the structural shift here is Math-Arena Apex. Let's dive deep into this one.
Okay, what is Math-Arena Apex?
It's a specialized benchmark. It focuses entirely on novel, multi-step, symbolic problem solving. It's designed specifically to require advanced planning and the use of external tools or internal scratchpads for logical decomposition.
So it's explicitly designed to punish models that just rely on simple memorization or quick, superficial algebraic solutions.
Exactly. It's a test of pure mathematical reasoning. And Gemini 3 scored 23.4%.
23.4%. Now let's look at the baseline here, because this is the amazing part. Why was the previous state of the art so incredibly low, around 1.1%? Claude 4.5 Sonnet only reached 1.6%.
That baseline of 1.1% highlights this immense symbolic logic barrier that existed for AI for years. Symbolic reasoning, the manipulation of abstract rules, variables, and axioms, is fundamentally different from human language processing.
And most LLMs struggled because they tried to map that symbolic structure onto a linguistic probability space. They treated math like a language.
Which it is, but a very different kind of language. To jump from 1.1% to 23.4%, that's a more than 20x improvement.
A 20-fold improvement.
It suggests that Gemini 3 has conceptually solved the underlying challenge. It's treating mathematical concepts as structured, executable logic rather than just tokens to be predicted.
A 20x improvement isn't an incremental gain, it's a chasm, as the sources suggest. It signals that Gemini 3 has accessed a fundamentally different level of analytical capability in this domain. It has unlocked true mastery of complex symbolic problem solving.
And that mastery, that ability to handle structured logic, translates directly into the next domain, coding and agentic intelligence.
Right, because coding is just another form of symbolic logic.
Exactly. Gemini 3 demonstrated clear algorithmic dominance in Live Codebench Pro, achieving an ELO score of 2439.
Which confirms clear algorithmic leadership over GPT 5.1's 2243. That ELO score is indicative of superior algorithmic creativity and general problem-solving ability in those competitive coding challenges.
It is. But moving beyond just coding efficiency, we see its strength in strategic capabilities validated by the Vending Bench 2 score.
Okay, you have to explain what Vending Bench 2 tests, because it sounds esoteric.
It's a fantastic benchmark. It's designed to test long-horizon decision-making under financial constraints and probabilistic outcomes. Think of it as a complex, multi-turn resource management simulation over an extended time frame.
So it's a high-stakes game of automated business strategy.
That's a great way to put it. It requires complex planning, predictive modeling, and resource allocation to succeed.
And the results here were overwhelmingly decisive.
They were. Gemini 3 delivered a mean net worth of $5,478.16 in the simulation. This is a massive 272% higher than the competitor average.
Wow.
This demonstrates its strength in strategic planning, multi-step coordination, and effectively governing complex, long-duration workflows. It's a direct translation of its deep think capabilities into simulated strategic action.
However, this is where we have to introduce the necessary skepticism and nuance. The benchmarks are not a clean sweep. This reminds us that the competition is fiercely specialized. Let's look at the debugging caveat, SWE bench.
This is a critical point that grounds the hype. It's so important. SWE bench tests real-world bug-fixing capability across massive production-level code bases from GitHub.
Real bugs, real code. And here, Gemini 3 scored a very strong 76.2%.
A fantastic score. But Claude 4.5 Sonnet was slightly superior at 77.2%.
1 percentage point.
It's a slim lead for Claude, but it's a crucial one because it reinforces this idea of competitive specialization. While Gemini 3 is the undisputed leader in abstract reasoning, mathematical proofs, and generating new algorithmic structures,
Claude retains a slight edge in meticulous, conservative, and reliable bug fixing in real-world, messy, large code bases.
Exactly. And this likely stems from Claude's foundational focus on safety, reliability, and conservative reasoning. Those qualities are paramount when you're trying to fix fragile legacy systems without breaking anything else.
That's such an important distinction for you to understand. One is the visionary architect designing the new skyscraper. The other is the meticulous, reliable, quality assurance specialist, ensuring a foundation of the old building is still sound.
A perfect metaphor. Now let's move on to multimodality and context leadership. We established that multimodality is native to the architecture. So how did it perform in tests?
It seems to lead visual comprehension decisively.
It does. In ScreenSpot Pro, which tests the ability to interpret complex visual interfaces, diagrams, and app screens, Gemini 3 achieved 72.7%.
And Claude was significantly behind at 36.2%.
Right. This suggests Gemini is far superior at synthesizing complex visual information, which is critical for engineers, analysts, and UI/UX designers.
And for dynamic content reasoning, the ability to analyze video footage, we have video MMMU.
Here, Gemini 3 set a new benchmark high at 87.6%.
That 87.6% score reflects its capability to analyze footage semantically and dynamically, right? It's not just relying on the transcribed audio or a few static frames.
Exactly. It understands object movement, temporal relationships, and complex context within the video. This makes it an unprecedented tool for journalism, security, or scientific analysis of dynamic data. It understands the story the video is telling.
Finally, let's look at memory leadership with MRCRV2. This benchmark assesses long context memory handling. We know the window is 1,000,000 tokens, but how do they test the reliability of that memory?
That's the key question. MRCRV2 specifically measures the model's ability to recall subtle, critical details that have been planted deep within that million-token context.
The needle in the haystack.
The needle in the haystack problem. They usually put the details at the very beginning or the very end of the prompt sequence. These are the areas where models typically suffer lost in the middle or edge syndrome.
And the results.
The 9.9% improvement over Gemini 2.5 Pro at maximum context sizes signals that their architectural design has significantly mitigated these memory reliability issues.
So this means if an enterprise user dumps in 1,000,000 tokens worth of data, a whole library of documents, they can be highly confident that the model will use the critical detail from page 1 just as effectively as the detail from the final page.
And that is essential for global enterprise systems that are dealing with massive, complex data sets.
Okay, so we have to step back now and summarize this head-to-head competitive landscape, because the sources are adamant, and the data shows the idea of a lone AI monarch, one model to rule them all, remains completely illusory.
It really does. It's a landscape of peaks and valleys.
Let me challenge that conclusion then. If Gemini 3 is so overwhelmingly dominant in reasoning and math, why should a user even consider the others?
Because specialization matters immensely. Gemini 3 firmly, and I mean firmly, leads in the analytical areas: abstract reasoning, symbolic mathematics, algorithmic creativity, and deep multimodality. It is, without a doubt, the superior analytical spine for any complex system.
But Claude 4.5 Sonnet, despite the huge gap in abstract reasoning, remains superior in conservative safety reasoning, ethical compliance, and that meticulous production debugging, which was confirmed by the SWE bench results.
It is the cautious, high-reliability choice. It's often preferred for sensitive legal, financial, or regulatory workflows where making a mistake is not an option.
And GPT 5.1, while it's been surpassed in these deep cognitive metrics, still retains significant advantages in narrative warmth, style, and conversational nuance.
It often remains the preferred choice for creative storytelling, marketing copy generation, and emotionally subtle writing, where that human-like interaction is paramount. It just feels better to talk to for many use cases.
Right. And Grok 4 remains focused on its niche: speed and cost efficiency, often specializing in rapid-fire analysis of dynamic, real-time data feeds like social media.
So the conclusion here is actually profound. Gemini 3 has shifted the entire AI battleground. The race has moved on from chat fluency, where, let's be honest, all the top models are now excellent, to cognitive depth, structured reflection, and analytical rigor.
That's the key takeaway from all these benchmark results.
It is, and that cognitive depth is entirely powered by the centerpiece of the Gemini 3 architecture, Deep Think mode.
Which brings us to part 3. We have to dedicate time to unpacking this mechanism inside deliberative AI.
You call it deliberative AI, which is the perfect philosophical term for what we're seeing. It signifies a move beyond mere reactive computation into something new.
So let's start with a clear definition, emphasizing the cost involved. Deep Think mode is not a separate model. It's a configurable operational state within Gemini 3 Pro.
Correct. It's essentially a metacognitive switch you can flip. Its primary purpose is to instruct the model to intentionally think longer when it's facing a complex, ambiguous, or multidimensional problem that can't be solved by a quick database search or simple pattern matching.
It's a mode that prioritizes analytical rigor over immediate response speed.
Precisely. So in its standard mode, Gemini 3 operates with high efficiency, optimized for low latency, using that MoE architecture for speed. But when you switch it into Deep Think, it fundamentally changes its internal operating procedure. It deliberately increases its own computational budget.
So what is the practical trade-off that the user sees immediately?
Latency. The immediate trade-off is latency. A typical query might take a second or two in standard mode. In deep think mode, a complex query might take 10, 20, or even 30 seconds.
Which is an eternity in computer time.
An absolute eternity. And it depends on the complexity of the internal paths it decides it must explore. But this is a deliberate internal choice, sacrificing that instantaneous intelligence for purposeful, structured cognition. The sources describe it as an internal metacognitive process.
This is the mechanism that delivered that massive supremacy in RCAGI2 and Math-Arena Apex. So we need to understand the 4 layered reasoning functions that activate when deep think mode is on, because these seem to be the components that build this new kind of deliberative intelligence.
Okay, let's examine the first mechanism, extended inference cycles.
So when deep think is active, the model avoids committing to the first statistically plausible answer it finds. It doesn't just stop when the confidence score is high, it keeps running.
Exactly. It actively evaluates multiple solution paths internally, and it often runs these parallel paths for a designated extended duration. It weighs the trade-offs, the robustness of the logic, and the likelihood of error for each path before it finally selects the most coherent and reliable reasoning chain.
It's like a scientist performing 5 different experiments to validate a single hypothesis, rather than just accepting the result of the very first trial.
That's a great analogy. That level of internal validation is a significant countermeasure against superficial errors and hallucinations, which leads directly to the second crucial function, self-verification and error correction.
This is where the model essentially polices its own output. It's a fact checker for itself.
Yes. It continuously cross-checks its own reasoning pathways and internal data points against established axioms or, if necessary, external tool calls. This is particularly vital in novel domains, like that IRC-AGI2 test where the model has no direct prior knowledge to fall back on.
And this is how it reduces hallucinations.
It's a key part of it. The model isn't just generating the next most probable token. It's confirming the logical consistency of the entire generated chain of thought before it gives you the answer.
The sources emphasize that this internal validation is the key to its higher reliability in those complex, ambiguous tasks where human scrutiny is often required anyway. Now, the third function, this sounds almost philosophical, multi-agent simulation.
This is the internal peer review system, and it is fascinating. The model simulates specialized reasoning agents. These are internal, optimized personas.
Like what?
Like a mathematical agent, a linguistic agent, and a strategic planner agent. And these internal agents debate and refine the proposed answer before the final output.
So it's mimicking human team consensus and cognitive diversity. It's forcing itself to consider a single problem from several optimized analytical angles before it finalizes the output.
It's simulating an internal think tank that is debating the optimal strategy.
That's profound.
Because it suggests the model is attempting to overcome the inherent bias of a single monolithic reasoning path.
It adds robustness and a kind of intellectual humility to the process.
It does. And finally, the fourth function, which provides the procedural rigor for all this, structured step decomposition.
This sounds like just breaking down the task into bite-sized pieces for analysis.
It is, but it's a form of procedural optimization. When a complex task is received, DeepThink strategically breaks it down into smaller, logical, independent units. This allows for iterative refinement and optimization of each independent stage of the problem.
And crucially, if a substage fails the internal self-verification check,
The model can backtrack and re-optimize just that one piece, rather than scrapping the entire long-duration reasoning chain and starting over.
it's like having checkpoints in a video game.
A perfect way to think about it. So you see how it all fits together. The MOE architecture provides the specialized experts, the million-token context provides the comprehensive data foundation, and DeepThink mode orchestrates the deliberation and verification across all of those resources.
And this synergy is what gives Gemini 3 its game-changing reputation in highly technical fields.
It enables what the sources are calling workflow governance. It can manage multi-step coordination across complex systems. It's not just suggesting a solution, but actually managing the execution and verification of that solution, because it has the cognitive resources to pause, reflect, and coordinate those pathways effectively.
So let's look at the real-world applications where DeepThink mode is absolutely essential. We're moving into domains that used to be exclusively human intellectual territory because they required this level of deep contemplation.
Absolutely. In high-complexity domains, we're talking about tasks that require long-horizon, nested reasoning. This includes things like complex logic riddles, generating solutions for chess-style strategic puzzles.
Or even designing complete AI-driven real-time strategy, or RTS game mechanics, which demands managing thousands of interdependent variables over long time spans.
Exactly. And in the corporate world, in business and research,
What's the killer app there?
deepthink is invaluable for detailed scenario simulation and optimization. For example, complex supply chain resource scheduling across volatile global markets, or high-stakes policy modeling, where you need to rigorously analyze how subtle shifts in input variables will cascade through the system.
And in academic research.
It's being used for novel hypothesis formulation and for generating step-by-step, highly detailed explanations of advanced theoretical concepts. It allows the model to act as a rigorous research partner, not just a search engine.
But let's bring it back to the ground. We have to return to the necessary skepticism. You can't have this level of rigor without practical, real-world trade-offs and constraints. What are the limitations on deepthink mode?
The primary constraint, as we discussed, is speed, latency. The slower response time means it is entirely unsuitable for any trivial query or task where near instantaneous output is required.
So you're not using this for your real-time customer service chatbot.
God, no. Or for quick data lookups.
Yeah.
You don't use a cognitive engine built for deep reflection on simple tasks. It's purely a tool for depth, not for speed.
And access isn't universal, even for paid users, correct?
That's right. Currently, it is restricted to the highest tiers. So it's available through the Gemini app's Advanced and Ultra plans, Google's Vertex AI for enterprise, and the AI Studio environments for developers.
And usage is often capped.
Often capped, yes, which reinforces its status as a premium high compute feature that organizations have to budget for. It's an expensive resource, and that reflects the energy required for all of that deliberation.
The sources also point out that even this incredible level of reflection hasn't eliminated all flaws. What ongoing limitations should you, the listener, be aware of?
We still see susceptibility to rare hallucinations in the most extreme, novel edge cases. If you push the model way beyond known scientific or logical boundaries, flaws can still appear.
It's not magic.
It's not magic. And furthermore, there are early reports of inconsistent memory handling, particularly in the most massive production environments. For example, when you're dealing with extremely large multi-file coding projects where all million tokens are completely filled, it has achieved extraordinary coherence, but not full, flawless, human contextual awareness across every single possible scenario just yet.
That brings us back to the philosophical realization we mentioned at the start of this section. Deepthink mode isn't just a technical speed bump, it's a milestone. It represents the birth of deliberative AI.
This is the out-of-the-box insight that really changes our view of the entire industry. Deepthink mode is the first practical, high-impact implementation of artificial intelligence that intentionally pauses, reflects, and revises its own findings.
It's a philosophical transition away from purely reactive models that just offer statistical replies, and it's a move toward reflective systems with structured internal reasoning pathways.
It's the blurring of computation and contemplation. It's not just executing code faster. It's stopping to ensure the code is architecturally sound and logically flawless before execution.
We are seeing the era of instantaneous reactive AI. The AI that simply pulls the statistically most likely answer being actively supplemented and in high-stakes domains replaced by an era of purposeful cognition.
AI that can genuinely think longer and harder about a problem, considering multiple scenarios internally. That distinction is going to fundamentally change how we assign problems to machines going forward.
Now that we've established the how and the why of Gemini 3's cognitive power, let's look at the direct application. We are moving into part 4. Real-world use cases and the cognitive operating system. How is this raw intelligence transforming actual industries and actual workflows?
The clearest and most immediate impact is in transforming software development. Gemini 3 is rapidly becoming a cornerstone in sophisticated engineering stacks, particularly for managing complex legacy systems where that million-token context window is an absolute necessity.
Let's go deep here. We're moving way beyond simple snippet generation. Tell us exactly what production-grade code means in this context. What are developers actually getting?
It means they're receiving complex, multi-component solutions directly from natural language prompts, solutions that are ready for immediate deployment after standard testing, of course. This includes generating complex shell scripts for system orchestration, modular components with inline documentation already written, and integration APIs that adhere to specific, complex style guides.
So it's about generating entire functional units of a program, not just filling in the blanks in a function.
Exactly. And its ability to handle large system logic is the key for one of the most painful corporate tasks out there, refactoring legacy code bases.
Oh, the nightmare of every senior developer.
That is where the context window and the deep think mode converge to deliver massive, massive value. Refactoring legacy code is typically a huge, costly, and extremely error-prone undertaking. Gemini 3 can analyze the entire existing, often spaghetti-like, architecture, the entire million-token system, propose modern, efficient architectural improvements, and then execute that refactoring using agentic tools like anti-gravity.
And it tests the changes locally before presenting them.
It does. So it's not just suggesting where to change a function name. It's identifying performance bottlenecks across thousands of files and rewriting entire dependencies from the ground up.
And its deep technical reasoning translates directly into superior debugging capabilities.
Developers are already referring to it as the new state-of-the-art for diagnosing complex, esoteric problems, things like performance bottlenecks, hidden memory leaks, and explaining compiler-level bugs that previously required days of a senior human expert's time.
That mastery of symbolic logic we saw in the Mathrina Apex score is what allows it to solve those incredibly niche, complex problems, right? Things like lambda calculus or type theory issues that stump conventional models.
That's the connection. And as we mentioned, the agentic tools are key. Through tight integration with IDEs and environments like anti-gravity, Replit, and Lovable, Gemini 3 facilitates incredibly rapid app creation.
And the agentic part means it's taking action.
It's taking action. It can facilitate pixel-perfect website recreation from just a simple screenshot or UI cloning of operating system components. It's not just suggesting the code, it's executing the changes within the development environment, testing them, and iterating. It's acting as a true intellectual co-architect, managing the project workflow from start to finish.
Okay, let's switch gears dramatically. Let's go to content creation and multimodal production. Since Gemini 3 is natively multimodal, this has to be a major area of transformation beyond just traditional text.
The immediate impact is on video and audio intelligence. Consider the ability to summarize long-form video into structured insights.
So I can feed it an hour of footage.
You can feed it hours of corporate training video or journalistic footage, and it can instantly convert it into digestible, structured formats, outlines, key quote extracts, or interactive timelines, all within minutes. This is invaluable for content strategists and journalists on a deadline.
And the sources emphasize that the power goes beyond simple transcription. It analyzes the footage semantically. What does that mean?
This is the core difference. It doesn't rely solely on the audio transcript. It understands what it sees, the emotional tone of the speaker from their facial expressions, the context of the location from the background, the relationship between objects in the frame, and what it hears holistically.
So it's the subtext.
It gets the subtext.
Yeah.
This allows it to, for example, convert a 50-page document into a podcast-style audio instantly, maintaining the narrative flow and incorporating emotional nuance in the synthesized voice based on the semantic understanding of the text.
This synthesis power also extends into visual design and communication.
Yes. When it's paired with spatialized visual tools like Nano Banana Pro and Higgs Field AI, which are high-end generation and manipulation tools, Gemini 3 is being used to generate highly technical infographics from raw engineering concepts and complex diagrams directly from dense academic papers.
It bridges the gap between pure data and visual communication rigor.
That's it. So a researcher can upload a 100-page paper on, say, quantum entanglement, and Gemini 3, using its deep think mode and multimodal capacity, can output presentation-ready concept maps and visual diagrams automatically labeled and accurate.
That's a massive efficiency boost in academia and corporate reporting.
We also see commercial applications of this via platforms like Arcade's AI and Typefully, where Gemini 3 is integrated to generate high-conversion ad copy, manage brand-aligned social media calendars, and optimize tone and engagement strategy based on rigorous data analysis. It's often outperforming purely creative models in results-driven marketing because of its analytical depth.
Moving into enterprise automation and productivity, this is where the speed and efficiency of the MOE model meet the depth of deepthink. This is what makes it a cognitive backbone for knowledge workers across the entire organization.
The sources detail specific, high-stakes business applications where that million-token context window is a hard requirement, not just a nice-to-have feature. Let's look at contract analysis, which is a logic-heavy, high-risk domain.
So how does Gemini 3 specifically change contract analysis compared to older AI tools?
Older tools could flag keywords. That's about it. Gemini 3 performs comprehensive risk scoring, and clause optimization by analyzing a new contract against every historical contract the company has signed and all internal policy documents simultaneously.
Give me an example of that.
For instance, it can detect subtle deviations in indemnification clauses that, while individually minor, might increase the company's cumulative exposure when viewed against the organization's entire legal portfolio, a task that is impossible for a human and for an AI without that immense context window and reasoning rigor.
That moves it from being a simple checker to a strategic risk manager. And for operations, what about SOP standard operating procedure creation and workflow generation?
For operations teams, the model can ingest all existing process documentation, identify redundancies or bottlenecks, and automatically generate optimized SOPs and complete workflow governance diagrams.
And because it can reason strategically, as we saw from the Vending Bench 2 score,
It ensures these new procedures are logically sound and aligned with long-term strategic goals, rather than just being a rewrite of the existing flawed processes.
and critically, strategic decision-making relies on its data interpretation skills. This is where the Vertex AI deployment for enterprise is key.
Organizations using Vertex AI are leveraging Gemini 3 for massive data synthesis. The model performs pattern recognition and synthesis of vast, multi-structured datasets, everything from internal sales figures to external regulatory filings and geopolitical risk assessments.
And it provides not just the insights, but the detailed, verifiable reasoning paths behind those insights. It shows its work.
That's so important. It's not just saying sales are up 10%. It's saying sales are up 10% because we adjusted the pricing strategy in Q3, which triggered a 15% increase in high-margin accounts in the Western region, but simultaneously decreased volume in low-margin accounts by 5% in the Eastern region, leading to a net positive revenue increase. And this conclusion is based on analyzing 4 terabytes of your operational and CRM data.
That transparency and verifiable reasoning path is crucial for high-stakes business intelligence.
Precisely. Organizations deploying Gemini 3 via Google's Vertex AI are reporting significant efficiency improvements, particularly in multilingual and logic-heavy tasks. They're positioning the model as a core infrastructure piece for strategic business intelligence.
Finally, we can't overlook the transformation happening in education and research. The way knowledge is taught and absorbed is changing because of this new level of cognitive power.
The sources heavily highlight the impact on what they call diagrammatic learning. Educators and students are using Gemini 3 to transform dense, abstract material.
Things like quantum physics, complex religious history, or abstract engineering topics.
Exactly. And it transforms them into visually navigable concept maps, interactive whiteboards, and storyboards. It uses its native multimodality to make these incredibly complex, abstract topics visually and cognitively accessible to more people.
And the personalized tutoring aspect is fascinating. How does it adapt to a learner's cognitive style?
So Gemini 3 simulates an expert tutor, one that's capable of adapting explanations based on real-time feedback from the learner. If a student is struggling with algebraic concepts, it can convert the textbook content into narrative, analogy-driven lessons.
But if the student excels with visual data,
It generates guided, step-by-step, diagrammatic problem-solving walkthroughs. It actively diagnoses the learner's cognitive block and then generates bespoke content designed to solve that specific block.
that is truly individualized instruction at a massive scale. And then there's the futuristic application mentioned in the sources, immersive learning.
This is a fascinating use of its spatial and temporal reasoning capacity. Educators are utilizing the model to perform photorealistic recreations of historical scenes based on spatial, temporal, and textual data derived from primary historical sources.
This creates what the sources are calling time travel classrooms.
Exactly. It makes history experiential and deeply immersive. Imagine being able to walk through a completely reconstructed marketplace in 16th century London, all based on archival data.
So if we look across all these uses, from refactoring complex legacy code with anti-gravity, to generating precise technical infographics with Nano Banana Pro, to sophisticated strategic planning on Vertex AI, the conclusion seems inescapable. Gemini 3 is evolving into what the sources term a cognitive operating system.
That's the core realization we have to leave you with. It is infrastructure. It doesn't just answer your questions. It orchestrates tools like anti-gravity or Higgs field AI. It integrates specialized data flows through its multimodality, and it coordinates thinking across disciplines using deepthink.
It's the central brain that manages complex digital workflows and intellectual projects.
And this marks the definitive transition from AI as a mere utility, something you pull up on your phone for a quick answer, to AI as true infrastructure. a foundational layer of the intellectual economy.
It positions Gemini 3, particularly in its deep think mode, as an intellectual co-architect for the 21st century.
The fundamental question for businesses, for researchers, and for individuals has now shifted away from, can AI help me do this, to a new question. How much of my strategic thinking pipeline can AI now own and execute autonomously? That is the strategic leap that Gemini 3 facilitates.
As we move to our final thoughts, let's just recap the magnitude of this release. Gemini 3 has absolutely established a new reference point, achieving structural leaps in mathematical and abstract reasoning, especially when it's enhanced by that revolutionary reflective deep think mode.
It is a major turning point. The benchmarks confirm its leadership in cognitive depth, abstraction, and strategic planning. It has redefined the state-of-the-art in fields like PhD-level math and novel reasoning by margins that were previously considered impossible.
But the final verdict has to remain nuanced. We must remember this. While it leads decisively in analytical rigor, it is not universally superior.
No, we still saw Claude edge it out in meticulous production debugging on SW Bench, and GPT often retains a decisive lead in creative narrative and that conversational warmth.
That's the crucial balance. Gemini 3's strength is its role as the analytical spine of a multi-model ecosystem. It provides the structured reflection and rigor that perfectly balances the conversational fluency of other systems.
The AI ecosystem is maturing into specialized high-performance roles. It's not one winner, and Gemini 3 now owns the high cognition deliberative domain.
The era of AI as a passive assistant is officially fading into the past. The era of AI as an intellectual co-architect has truly begun. This shift from speed to structured contemplation is the new starting line for the entire industry.
And that brings us to our closing thought for you, the listener. We've discussed in depth how this deep think mode represents the first practical implementation of deliberative artificial intelligence AI that pauses, reflects, and revises its own logic. It's moving from reactive, pattern-based intelligence to structured, self-critical contemplation.
So the provocative thought we want to leave you with is this. What domains of human problem solving, the ones once thought secure and reliant on uniquely human reflection, abstract strategic planning, and complex cross-disciplinary synthesis? What domains will be the next to face this level of machine reflection? If AI is now designed to pause and think better than you, what does it mean for you to be profoundly smarter when you're competing with a cognitive operating system designed for coordinated multi-agent reflection and flawless symbolic logic? That is the ultimate question of the convergence age.